So in this way, we want to talk about an easy to understand concept, but a super powerful one, and that is probability. So whenever you need to kind of do something by a certain amount where you don't know, how much of something you have, you can work with probability. So for example, in this case, I want to take this sphere and delete, let's say, 10% of all points randomly. How do you do that? It's actually surprisingly simple. First of all, of course, you can delete points with the remove point command, and it works like this. You define the geometry first and then what number you want to delete. So if I want to delete myself, that's the command. And now the trick is really simple. You just use a random number, which by default is between 0 and 1, and you put this into an if. So for example, I say, if a random number based off my current point number is lower than, let's say, 0.2, then delete me. And this is already probability, because when we know that out of the random function comes a number between 0 and 1, then there is by definition a 20% chance that it is below 0.2. Or if I turn this around, now there is an 80% chance that it is above 0.2. And all of a sudden you have probability, and you can use that with everything. So for example, you could say, I don't know, I have points here. So of course that doesn't only work with geometry, but I can say I have for some reason a huge amount of points, but I only want to keep 10% of them. Then I just change my code here to this, and actually it should be like this because I want to delete 90%. And then that's it. I keep the same overall distribution, but I just threw away 90% of those points randomly. Let's quickly check if that's true. So here I have 100,000, and what comes out of it is roughly 10,000. There's of course a little margin of error because it's a probability. It's not a guaranteed result. Just a small note here, you might have noticed this is a concept we've very briefly seen before when we talked about groups in the basics chapter, and the group expression node uses that concept here in one of the presets. The 30% chance logic is the same. So this is a concept that we potentially have seen before, and you can see here we can select 30%, for example, if we change the number, something else of course, of points or primitives or whatever. So this concept is used somewhere else, but in my opinion it's super helpful to understand it in context of Vex, because then you can use it for much more than just group members. So just a small side note here. So let's look at another example of what we can do with this. And that is, we can actually use that in combination with simulations. So for example, what I have here is a simple simulation of some dust particles. So let me quickly clean this up. So here we have it. It's a relatively simple point simulation, and it's a bit hard to see, but those points here are simulated, and they are simulated and colliding with this environment. So let me quickly create a playblast so that we can see that, hopefully. So this is how it looks like. Nothing special, really just a couple of points with a bit of pop force and all that kind of stuff. But what we want to do now is, if you only render points, it's a bit boring. So let's add a little bit of geometry on those. And what you want is, of course, not that every point gets replaced with a geometry, a piece of paper or whatever, but you want to only take a few of them. And this is where probability comes into account, because what we can do is we can just, with our code again, delete everything except 5% of them, let's say. So again, very simple. We use a random and say, okay, delete everything that is in the 5% margin. No, actually I made a mistake, but I will fix it in a second. So of course this will only delete 5%. So I have to turn this around and delete everything that is not in the 5% margin. And now what's left is 5% of all the points. And now, I just take some piece of paper that I use a grid for and then copy to points. There you go. And now I create some random p-scale for that. And then I add a random rotation to this. And I use N and up for this with a curl noise. And when I playblast this, we can see that about 5% of all points are replaced with our paper here, which is nice. But when I run this, you can see it feels like kind of weird. It's maybe too fast or something. Well, what's happening here is actually the points are flickering, and that is because I made a mistake. I used in the random probability deleter the point number, but since this is coming from a pop simulation where points are dying, the point number is constantly changing. So of course what I should have used here is the ID as an input, and the same is true, by the way, for the p-scale randomizer, because this currently takes the point number as well as the seed attribute, which will result in a constantly changing size of the points. So let's make sure we use the ID for this as well. And then it could look like this. So, of course you can add more geometry to this, not just a piece of paper. My point, of course, here is that probability is a nice way of kind of using your simulation then after you simulated it. And then as a bit more advanced version of this, you could actually not just delete a certain amount of points, but you could make sure that there's always a certain number of points no matter what the input is. What do I mean by that? Let's say you have a simulation here that you like, something like this, but you can't change it anymore and you have too many points. So let's say you want to have the same kind of feel to it, but only 10,000 points at any single moment. What you could do is you use the same technique, but instead of calculating it yourself, you calculate the probability before you use it. And you can do this by just saying, okay, I take my 10,000 and divide it by the number of points that are already there, which is saved in the numpt attribute. And this way, what comes out of this is a probability, okay, how many points of the original is that between 0 and 1, because 1 would be all of them, but it's probably in this case something like 0.1, so 10%. And then I use this probability, of course, the way I'm used to. And again, I use the ID here, not the point number, and say, okay, if it's smaller than my probability that I automatically now calculated, then delete the points. And of course, I made the same mistake again. It's the wrong way around. It has to be higher because I'm deleting everything else. And what I end up with is an error. Oh, because here, what happens here is a data type conversion again. So let's quickly check this. What comes out of the probability. And as we can see, there's just 1 point. And the probability of this is exactly 0. And that is because I typed in 10,000, which is an integer. So I should have typed in 10,000.0, which is a float. And then I get a correct result. And that is 0.104 something. That's the probability that is needed to create 10,000 points relative to the current point number. And as you can see, this creates the same overall structure, but with way less points. And it roughly, not completely, but it roughly keeps 10,000 intact. It's not exactly 10,000, but about 10,000. So even if I increase the number of points for this simulation, I would still at the end get 10,000. It's just that the probability is changing based on the amount of points that is there. I hope this makes sense. This is a bit more of an advanced use case for this, but it's just interesting that you can calculate your probability yourself. You don't have to know it beforehand, as long as you know how many points you want. All right, so I hope this is helpful. Probability is easy to understand, but very powerful. So thanks very much and see you later. Cheers.